All right. We are live. Hello, everyone. Welcome to this particular webinar on production OpenTelemetry with Kubernetes. My name is Kunal. I'm working as a DevOps engineer at Randoli. And first of all, really apologize for the delay. The internet gods weren't with us today. There's a slight bit of lag between me and Yash, but I think we all can figure it out. But I'm very happy for Yash to join in this particular webinar with me. Yash, would you like to introduce yourself and tell everyone what you do these days?
Hey everyone, I work at DigitalOcean as a developer advocate. As you can see, I really work on the cloud native area, Kubernetes, and contribute in the cloud native ecosystem. I'm also a maintainer of a project called Mishri. It's an open source CNCF sandbox project, helps you manage your cloud native infrastructure. So I'm really excited to be joining Kunal today and talking about a lot on OpenTelemetry on Kubernetes.
Amazing, yeah, and we are very happy to have you here as part of the webinar as well. Maybe I can give my introduction again. Hey everyone, my name is Kunal. I'm working as a DevOps engineer at Randoli. I am also a CNCF ambassador. That just means I really love cloud native, and I love to help people get started in cloud native and love to advocate for cloud native technologies. These days, you'll find me mainly working on OpenTelemetry, cloud native observability, and all sorts of things, right? So you can definitely reach out to me, reach out to Yash if you want to have a conversation around anything cloud native, because we are both very much involved. All right, so without further ado, today we are going to talk about production open telemetry on Kubernetes, and we are going to talk about infrastructure observability, application observability, and how open telemetry unifies them in production. So Yash, take it away.
Sure. Today we will be talking about, as I said, we will be talking about observability part and what observability is and what is mean, right? So let's start with understanding. I think in this webinar we will not be going deep dive into what actually observability mean, but we'll be touching upon it and we'll be doing at the last of this link in the webinar. You will have a very great demo as well, showcasing how that works and everything. So first, let's talk about the infrastructure observability and why it actually matters. So, okay, the key point for infrastructure observability or the key question is like, is my infrastructure healthy, right? This is the key question we ask when it comes to the infrastructure observability part. And why do we actually do it? Why do we actually want to measure it? As I said, we want to make sure our infra is healthy. And in observability there can be different areas which you track and monitor, which is like one can be application observability, one can be infrastructure observability. On the infrastructure side, you usually in the production make sure you manage, track or monitor the node health. Maybe for my Kubernetes cluster, how's the node health going on, what's the CPU usage, what's the memory usage, what's the disk usage, right? How's the network going on? For you it can be control plane as well, like is my API server working fine, like it's the etcd working fine, it's the scheduler working fine. You need to track all these to ensure your infrastructure is healthy. Also the pod life cycle is there, the scheduling is working fine. On the network layer you can you want to track or monitor about the CNI, DNS or service mesh if you are using it for your network and network policies. On the storage side, you want to make sure the PV and PVCs are working fine. Sometimes you get very hidden issues with the IOPS. You want to monitor it as well, right? And since you monitor all of them, will help you track down and debug the issues faster. Now we talked about what we actually monitor. This is the part of the observability we do, but it comes with a lot of challenges because Kubernetes itself is very complex. It's not easy to track every part of Kubernetes, right? If you think about it, let's say if you want to create your own something of your own observability, right? You are doing it manually by yourself without using any open source project. You can think of like, okay, pod is getting scheduled, but Kubernetes auto scale the pod or Kubernetes auto deletes the pod. So there is a dynamic nature inside the Kubernetes, which is not like it's a fixed thing that you can just track it with manual walk or something that you have built or wrote a script, something like that. right? It comes with a dynamic nature itself. So this is one of the thing which comes when you try to monitor by yourself, but we have a lot of open source projects nowadays which can help you do that. But let's talk about the main engineering points that you may be facing right now is, and maybe SRE or DevOps engineers, like multi-cluster visibility gap. Sometimes you have multiple Kubernetes clusters. Each has its own Prometheus running inside it, but you don't have a single dashboard, like say not a single pane of glass where you can just look at it and you can figure out, okay, here it's my multiple Kubernetes cluster, and um, here is all the issues that we are getting. So you will get these kinds of issues as well. You will get the metric cardinality explosions, like when we are talking about small clusters, like maybe 2 or 5 clusters, it's fine. But when we talk about maybe 100 cluster, 500 cluster, maybe our organization running thousands clusters, right? It runs like at DigitalOcean, we run thousands of clusters, and it comes with a lot of challenges, because now you can think of, if you are running hundreds and thousands of clusters, or even hundreds of cluster, how much metrics, logs, and events all of the services, pods, and might be generating, right? And this can choke your Prometheus. This can, explode the cost you have with your um, observability platform. So these kind of challenges also comes on the infrastructure side. We will be talking about how you can, solve these. We will be talking about how Randoli helps as well. So if you can all, if I talk about like control plane black box, it's like is ATCD latencies, API server slowdowns. These kind of challenges also come with when you scale on the infrastructure side. On the also about the storage, let's say you have PVC latencies, IOPS. As I said, IOPS issues. I heard a lot of people having it. A lot of teams sometimes pinpoints each other, and then later on they figure out, okay, there was an IOPS issue. So you manage all of these. You try to do that, but these are the one of the common challenges you face when you talk about observability. Next, I'll hand it over to Kunal to talk about more on the application observability side.
Amazing, pretty interesting points there. And some of them we'll definitely connect back to in the future as well in subsequent slides. But we have talked about the infra now, right? But let's flip the lens and take it from the applications perspective, because in production, nobody wakes up to, hey, CPU is 80%. They may wake up to, hey, checkout service is slow. You might have set an alert for that. Error has spiked or the user has been impacted, right? So when we say application observability at scale, we mean we can we understand the application behavior reliably, and that too under production conditions, right? By the way, if I'm looking this way, I am looking at the chat and I'm just looking at all of the comments here. And if I'm looking this way, I'm looking at the slides and the camera. Just a quick prompt there. But quick show of hands in the comments, if when there is an incident, if you're a DevOps engineer who's watching, what's the first thing that you check? Do you check whether the user has been impacted, or you have set up your SLAs, or is it the dashboard itself or that particular alert? Would love to know. But let's first start with what exactly do we mean by application observability at scale, right? Because this is where things start, and it all boils down to a few core principles and a few core questions that we ask from ourselves. A TLDR of this is that it's all about understanding application behavior in production, right? Under real traffic, under real failures. Now, when something goes wrong, you might find yourself asking these typical questions, right? Is this impacting users, or is this impacting my SLAs right now? Which service or which dependency is responsible for this? Or what change in, let's say, the application? Right now we are talking about the application, but later on when we'll connect the infrastructure context as well, because that's the whole point. What changed in the infrastructure, or what changed in the application that may have led to this behavior? And the reason this becomes hard at scale is because each of these questions require some kind of correlation, right? And not just isolated charts of different services that you have. So now in productions, these questions, if we look at some production realities of modern applications, these questions become hard because the issues are rarely contained in one places, right? At production scale, application issues are really isolated, and they are not obvious at all, right? You might find at production scale, you might find that there are a few realities which show and a few realizations which show up again and again. Failures across service boundaries, right? Because requests cross different services. There are a lot of services, especially when we talk about a distributed system and running at a large scale, right? Most incidents are triggered by, some of the incidents are triggered by changes. Like, for example, you change the deployment, there's a configuration change, traffic shifts, right? Sometimes there is a spike, so traffic shifts, and these kind of behavior shifts are pretty hard or comparatively harder to correlate between each other, right? And most of the failures are partial. It's not like a full outage like happened with AWS multiple times last year, but it's a partial failure with one service, and it might affect the connecting services. So again, the correlation becomes a bit sort of a human workflow, right? And this is exactly why when we say it works at staging doesn't mean much, because production has different failure modes that it's important for us to keep a track of, right? So the question remains again, the challenge is that why app observability gets harder at scale. That's a very important point for us to understand, because the challenge isn't having telemetry. Because today, if I talk, there's a very good example of this. Last year I was giving a talk at KCT Bangalore, right? And one of the first questions that I asked the audience was, hey, all of you, who has some kind of an observability stack going on? Literally everyone raised their hands, right? So it's not a question about whether you have telemetry. The challenge is, how are you able to extract and correlate different signals from the telemetry, right, across the different scope, across different scale at which you are working? Because if you look at in a different way, right, telemetry in real world, in production scenarios, is produced, per pod, right, per service. Sometimes the service could contain multiple pods, and that particular service might be dependent on multiple services, right? So all of these particular components, if we talk in terms of Kubernetes, these are generating telemetry data, right? And as I mentioned, in production, failures don't affect everything simultaneously, right? It's not uniform. Failures don't hit every replica uniformly. One pod can misbehave while the next one could look fine, right? So staring at one service or one pod in isolation can be a bit misleading. That's why I mentioned the most important point here is that having telemetry or having raw telemetry does only one part of the job. There has to be something which extracts the data, which extracts and correlate the signals, right? And this sort of bridge into a couple of examples I'll give you just to clear out this particular picture. So let me give you a couple of scenarios which might help you to sort of correlate what I'm trying to say here. Let's say, for example, this is a particular scenario where a user is trying to access the order service, and the order service, it has two particular pods, right? So this is a very good example of a partial failure, right? It's the same service, but it has multiple pods, and one pod is behaving differently. Now, if you're a DevOps engineer, from the application dashboard, you might see, okay, there's a P95 latency of the order service going up, right? But it's not across all the pods, right? If you only look at the surface, if you only look at the surface level of that particular surface, you may look at, oh, only one pod is healthy, right? That's it. It's all good to go. But if you deep down, if there is a correlation between the service and per pod basis as well, this is where we need a correlation, right? So the request trace, and we'll be able to correlate, okay, one pod is behaving correctly and the other is sort of, because of a high payload, the memory is leaking for that particular pod. So that kind of a correlation is what we need in production. There is another scenario, right? Scenario number 2 could be different services connected with each other, right? So there could be an upstream service like an order service. On a surface level, it might look like on the dashboard, this order service has high latency, high error rate. But those are the symptoms, right? The real root cause could be, okay, this order service is talking to Kafka, which is a downstream dependency, right? The real issue is that Kafka is throttling. The Kafka broker is throttling. It has increased publishing latency. So the order service is just the messenger. And that's why, because there is a delay between the event publish, that's why you're experiencing a high latency in the order service. So that's the root cause. So I hope that you're getting an idea of what kind of correlation I'm talking about when it comes to production. And these are certain scenarios that will help you to understand. But the point that we are trying to cover today is how infrastructure context is related to application. So this is a really good example to show that. For example, you have a node, right? An application is running on a node, and you see that okay, because there is a lot of CPU and memory pressure on that particular node, that affects the pod inside it, that affects the service inside it. But as a user, you are only seeing the symptoms, which is the order service is experiencing high latency. But the root cause is because the infrastructure or the node on which the application is running is experiencing high CPU and high memory. I hope this paints a good picture in your mind, and this helps you to see that why correlating application signals and infrastructure context is very important. Both of them depend on each other, right? Application only signals might show the symptoms, but infrastructure correlation will show the cause. And this can be vice versa as well, right? Application infrastructure signals can show the symptoms sometimes, and the application might show the cause, right? So both the context is important. And I think this is something that Yash is going to cover in, and me and Yash are going to cover in the next section as well. Over to you, Yash.
Great. I do agree with you, Kunal. And you can't, when you scale, you can't just figure out. Sometimes issues are just not on one side. You can't just figure out the issue on the based on the infrastructure observability. Sometimes it's related to infrastructure, but app observability, the team from the app side thinks, okay, the issue is from the side. So it's very common. And so let's talk about like why infra and app observability are often disconnected at scale, right? So when you try to manage your observability at scale, you will figure you will face a situation where you now manage infrastructure separately, infrastructure observability separately, and you manage the application observability separately, because it makes sense. Why it makes sense? Because you have different kind of workflows. Like on the infrastructure observability side, you talk more about the node scalability, right? Not like CPU says, pod scheduling and everything. When you talk about the application side, like the Kunal was talking about, you talk more on the side of maybe request latencies, like the DB queries and things. So both have different goals and incentives, like as I mentioned in the PPT, like both have different goals for their observability side. Now the challenges come like when you have different observability team, it has different levels of abstraction, it has different levels of data sources as well. So like for let's say different, so I already talked about the abstraction, like for the part of the application observability and for the part of the infrastructure observability. So different level of abstraction can be like for the application, it has DB queries relating with the backend and everything. So you are tracking the latencies in the request, but you don't do that in the infrastructure side. So you might be also having telemetry spread out of different sources. Maybe let's say you are using any cloud provider service, right? So you have metrics coming from the cloud provider service. You are using maybe in the application side, maybe you are using any other kind of service to track logs, right? To track the events for your metrics. And now you have metrics coming from that application part as well. Now there is not a single place you can find it, but your metrics is spread across all of the services that you are using. It can be cloud provider, it can be any other parties that maybe you install agents to track your application backend, maybe for its logs and events as well. So these are the realities in the production we are talking about. Now let's talk about like what breaks when signals don't correlate, and what actually happens when the infrastructure observability and the application observability doesn't correlate in your team. It comes with longer MTTR because each team pinging each other. Okay, the issue is from your side because they are not able to figure out what's the actual issue is, and they may organize a meeting at last, and you will see that okay, they are in a room for 1 or 2 hours just to figure out issue was from someone's end or issue was the IOPS issue, which could be easily figured out. Sometimes it happens. And wrong attribution of the root cause, there may be multiple cases where you will see that the application is failing, but the and application team gets the PagerDuty, and they say, okay, they start working on it, and they see, okay, everything is working fine, and the issue is not from their end, but they later figure out the issue was from the infrastructure side. Some pod was leaking, or there was some issue from their side. So they don't have actual correlation between them. So if I give you an example, maybe application team gets you know, PagerDuty about an particular issue, and then infrastructure side says, or maybe let's say application says, okay, our application is down, and they tell infrastructure observability team that, okay, what's going on, and infrastructure observability team says, we gave you all the required CPU usage or whatever you required, right? So why this issue is on our side? You requested and we give it to you. Then application side says, okay, but we are still, our application is still down. And maybe then observability side will say, okay, you requested for this amount of CPU, but this should be your issue, right? You should know. And but application teams and say, we don't know how much CPU usage we needed for our application. So you can see like teams are getting just pinpointing each other. They don't know what's going on. For from infrastructure side, they're saying, okay, everything is working fine from our side because you requested and we gave it to you. But applications team is saying, okay, I know you, we requested, but we didn't know this will cause the issue. So there is a lot of correlation issues comes when you scale with the observability. Higher cost and lower clarity, obviously. Different teams using different services. Some team might use different services, like maybe other one team is using Datadog, one team is using New Relic, or maybe one team is using from infrastructure side using different tools as well. So they don't have single service. It comes with higher cost. They don't have a clarity between teams and what's going on. So all of these combined together cause the longer MTTR, and you will see that customers are still facing the issue and the application is still down. Yeah, over to you, Kunal. I think, yeah, next we will talk about more on what we need to do.
Amazing. Yeah, I think so far, I hope the audience is with us as well. Write it in the chat if you are still here with us, if you are able to understand. But so far, we have seen like why app and infra context needs to be together, right? How is it important for the infra teams to understand what is happening in the application? How important it is to for the applications from the applications perspective to understand what's happening in the infra, right? So both of these go hand in hand. But in practice, what exactly do we need, right? What are the requirements? We need a unified observability approach that gives us that context across the infrastructure and application, right? And we have very basic requirements, right? We need a common way to describe uh, context across the infrastructure and applications. We need those common identifiers. We need to derive signals from telemetry. As I mentioned, raw telemetry is only helpful up to a certain extent. But if you want to build that correlation, it's important that you extract signals from the raw telemetry data, right? And correlate things across the fleet. By across the fleet, I mean not just isolating to one particular service, but as I mentioned, there is telemetry per service, per dependency, and per instance as well. So it's important that you correlate it across the fleet and across your entire infrastructure. And we need unified pipelines. As I mentioned, if you have a Kubernetes cluster, but you're using multiple data sources, that means either you're using managed virtual machines, managed services, for example, managed databases. If you're using DigitalOcean managed databases, for example, you need a unified pipeline to connect all of them together, because those are part of your infrastructure, right? Those provide you the context that you need from the infrastructure angle, right? So these are the things that we need. And this is where we believe that this is exactly the problem OpenTelemetry is designed to solve in the first place, right? Now, why OpenTelemetry fits our problem? It's important for us to understand this. OpenTelemetry, if anyone in the chat is not familiar, it gives you a standardized way to collect, export, and process the telemetry data across different backends, right? But it does a bit more than that. It provides you a common foundation where you can collect and correlate the telemetry data from your application and from your infrastructure, right? It gives you that out of the box correlation that you need, that we have been talking about till now, and which is why it's important in production as well. So what does it do? It gives you standardized context across your entire infrastructure and applications, which is what we need. It's vendor neutral, so all of the metrics, logs, traces that you collect is vendor neutral, right? It's built on top of open standards. That means you can send your data anywhere to whichever backend you want to use, whether that's a OTel native vendor, for example, Randoli, or whether it's open source tools like Prometheus or Jaeger and all of those, right? The main point is it was designed for distributed systems from day one, right? And that's sort of the core USP of why OpenTelemetry fits our problem today. So what OpenTelemetry enables now, right? As I mentioned, it gives you that unified observability across different layers, which is what we need, right? It gives you those consistent identifiers for pod services and nodes, which is what we are gonna see in the later slides as well. It also helps you. It gives you that correlated telemetry view, right? And it helps you to extract the signals from the telemetry data, which is something that goes beyond just raw telemetry, which is what you need. And as I mentioned, if you have multiple data sources, it gives you those flexible pipelines, which I'm going to cover in the later half as well. And that is what is something that it enables teams today when you're running this in production. So this is a very, I would say, bird's eye view of how this might look like if you're using OpenTelemetry now, right? So we have the applications running inside a Kubernetes cluster. It could be, managed Kubernetes cluster or whichever way you want. And you have the application level signals plus the infrastructure level signals which are coming, right? And because these are going into a single pipeline, which is the OTel pipeline, you are able to build that kind of correlations, right? Which you need in order to debug or troubleshoot any incidents, right? You need correlation on both the sides. I hope this makes sense now. All right, so we have talked about OpenTelemetry, how it helps, right? How it gives us context, correlation, and a unified pipeline. But let's now talk about, and this is one of the main topics of this particular webinar, which is taking OpenTelemetry to production, right? Because when you take things to production, it's a bit different, right? Production scenarios are a bit different. In production, the work or the purpose of OpenTelemetry shifts from just being a collector of telemetry data to running scalable and reliable telemetry pipelines, right? These are certain aspects that you need to keep in mind when you're running OTel in production. And you need to set the clear expectations, right? Because why I mentioned that it's a bit difficult or it's a bit different to run OpenTelemetry in production, because in production telemetry volume increases, right? It's a bit different from the staging environment. There are different failure modes. As I mentioned, there are partial failure modes, and which might not be visible at a very first instance, so you need to keep that in mind. There are different scalability challenges, with the user. We have been working with multiple users right now at Randoli, and every time we get on a call with someone, there's a very, very different use case about how they're using OpenTelemetry and how scalability issues affect their usage, right? So that's a very important point to understand, and we'll cover that as well. And there is also an aspect of operational ownership, right? Who owns the pipeline itself? Who owns the maintenance of the pipeline? Who is owning the instrumentation part of things, right? So there are these different configurations, and there are these different points that you need to keep in mind. But Kunal, where do we get started with, right? So what we are doing now is, if you want to run OpenTelemetry in production, these are the 5 areas to get right. And these are the lessons that we have learned over the period of time talking to multiple users at different scales at Randoli, right? I've been interacting with users on a daily basis now. And these are the 5 areas we definitely believe that if you are looking to get OpenTelemetry to production, these are the 5 areas that you need to keep in mind. And these are the 5 areas that you need to get it right in order to fully use the capabilities that OpenTelemetry gives you. So the number one is security, right? You need to ensure the security and the stability of the collector itself, right? In real systems, again, telemetry doesn't only come from inside Kubernetes, right? You might have a browser, you might have mobile applications, you might have virtual machines, managed services. all sending data in, right? That means your collector is also an ingestion surface, right? So it must be secured. And there is a what you can do is here you can use edge collectors with TLS and authentication to receive these kind of telemetry data from outside your cluster. Example, front end application. In the demo that we have today, I'm going to show you a real example of this, how this is implemented and how this looks like, basically, because we have a pretty interesting demo up ahead. But the main point is that because you're getting telemetry data from outside of your environment, it needs to be authenticated, right? TLS monitored. The second point, which is very important to understand, is because telemetry traffic is bursty, right? Deployments, incidents, and retries, without a memory limiter, the collector can often, the first thing is ohm killed, right? So the stability of the collector itself, which is your central point of collecting all the telemetry data, that is important for you to maintain, right? And the third most important thing here to maintain the stability is batching, right? You should batch your you should batch you should use the batch processor to batch your telemetry data, right, when you are sending it to your particular backend. And it reduces the connection churn, and it improves your throughput, and also protects the downstream backends where you're sending your data, right? So if you focus on stability first, and then and then the rest of the points, I think you are on a right path. So that's my first recommendation to you. The second one is as important as the first, which is observing the OpenTelemetry pipeline itself and treating it like a production service. Now, here is a mistake we see a lot with the conversations that we have. Teams use OpenTelemetry, right? But they are not observing OpenTelemetry itself, right? Which is also an important aspect. If the telemetry is critical, the pipeline that delivers it must be observable too, right? That makes sense. So you need to watch the collector's health metrics. For example, how much data is being dropped, what's the queue size, what's the queue depth, things like exporter errors, retry counts. If you see this particular dashboard, this is from one of our dashboards, which gives you a complete visibility into the hotel pipeline. But it's important that you have visibility into these metrics as well, apart from your applications and your infrastructure. And it's not just about having the visibility, it's also about setting up the alerts, right? So that you get notified, you get alerted on when these things are when these things happen. I'm sorry. The last thing is you should also define SLOs, not just for your applications, not just for your users, but you should also define SLOs for telemetry, right? Because if your telemetry delivery is reliable, then the rest of the things that you do, the insights that you get, and during the incidents, the root cause analysis and the troubleshooting will get easier for you, because your telemetry data, which is setting the base for everything, that is correct, that is stable, right? That is reliable. So this is the second one. The third is standardizing context, and this is very important for correlation, right? Most observability platforms at scale are actually, it's related to naming problems, right? And it's not the lack of data. It's what we have seen is it's a little bit lack of consistency. OpenTelemetry gives you OpenTelemetry semantic conventions, right? Let me know in the chat if anyone is familiar with OpenTelemetry semantic conventions. And these are very important for you to use. So you should leverage standard attributes for capturing key information like service.name, service.version, your environment, for example, deployment environment, right? And if you're on Kubernetes, you can add these particular annotations to your deployment to capture these key details. And in turn, when you're trying to visualize this data, this helps you to, first of all, correlate between different services, right? And this also helps you to increase the quality of the data that you're sending, because you're sending that with these key insights. Again, having consistent naming across telemetry and trace level attributes is very important as well. We often see numerous examples of, as you can see, different ways of writing the same thing, right? So status underscore code, status code, and status.code. So you can see how this will play out in production if you have these things going on, right? So these are a couple of things that you can do in order to improve your correlation that happens, right? OpenTelemetry gives you these out of the box, but these are certain things which are under your control. And if you keep this in mind while you are trying to get OpenTelemetry to production, your correlation will be it will be very helpful for you and will be far much better. Let's talk about sampling, right? Because sampling is something which is a little bit, people find it a bit complex, but it's unavoidable at scale. The question isn't whether you sample or not, right? Sampling means, you are sort of selecting what to send specifically in terms of distributed traces. When we're talking about traces, right, it's not about what you sample, it's about how intentionally you do it and what's the reason behind doing it, right? Because the worst thing you can do is you can sample differently in every service. That's the worst thing that you can do. And there's an example that I'm showing you here, which is very much, I hope you are relating to that. It's about applying consistent sampling rate across service and dependencies. Let's say the order service and the product catalog service are connected. You can't apply a sampling rate of 100% to order service and let's say 10 or 20% to a product catalog service. Like, it won't do you any good, right? It will lead to dropping off data, right, which we don't want. So it's important that not all it's important to also understand, basically the second point, it's important to understand that not all the requests are equal, right? For example, in the diagram, we have the order api and the user is making requests to it, and the checkout and the login service, or the login checkout and login request, are business critical. So you should sample 100% of them. That means there won't be any data drop. But let's say there are certain services, for example, which are sort of low value, right? Background task or asynchronous request. That is something you can sample, which is what it will do is it will reduce noise in the telemetry that you're sending. And if the telemetry has less noise, that means you're sending high quality telemetry, high quality signals, which will in turn help you when you're trying to debug an issue, because it is increasing the quality of your insights as well. So sampling is really important, but it's also important to understand when to sample and be intentional with that. The last, but definitely not the least, is how can you improve the data quality, right? Because how can noise is something, if you're sending everything, even if you're using OpenTelemetry, if you're sending everything to your backend, that won't do you any good, because you might be sending noise unintentionally to your backends, which in turn won't help you, which in turn might cause you to sort of increase your mean time to response when you're debugging any incident, and we don't want that, right? So there is one line which I really like about this, and this is something that I've been talking at multiple events as well, that more telemetry does not mean better observability, right? It's not that the more you send, the better your observability gets, because noise is expensive. It's financially expensive because you are paying for what you're sending, first of all, and if you're sending noise, that means you're paying for that as well. But it's also a cognitive load, because now during an incident, the insights that you'll get are not accurate, right? And your setup may not directly impact your mean time to response, right? We want that to be lower. So filter the noise early, drop the debug logs, then low value spans which don't belong in the production pipelines. Drop them early before they consume the storage and your attention, right? That is very important. And something which Yash also touched upon in where we was explaining the infrastructure challenges is cardinality, right? So this is sort of a very common mistake that we see many users make, which is putting uh, if you can see the example, not normalizing the labels with change. For example, if you see in shipping service, there is an ID which will keep on changing with every request. So this is a high cardinality data point, right? The solution for that is you normalize it. For example, use labels like order ID, right? So either remove or normalize high cardinality attributes such as user ID, request IDs, and as labels, for example, right? So normalization keeps the relevant signals that you need, but without exploding the volume of your telemetry data, and in turn it helps you to get the insights that you want, right? If the data is noisy, if the data is inconsistent or incomplete, teams will stop using it, and it won't make sense. So now that we have talked about this, right, we have talked about a lot of things related to infrastructure, application, how OpenTelemetry helps you in that. I just want to quickly take a moment to show you a really quick demo of how this may look like in production and how the setup will work, right? So let me unshare my screen, and feel free to ask any questions in the chat as well. um, I was not able to see the chat the whole time, so I hope, Yash, you are able to see that. But let me open up a dashboard to show you what I mean by this. And the whole purpose of the demo is to bring everything together for you all, so you are able to understand this. So, okay, I hope you are able to see my screen. So what we have is, and this is interesting. So what we have is a MERN stack application. How many of you have worked with MERN stack? Raise your hands in the in the chat. Yash, have you worked with MERN stack before, by any chance? Yep, you have worked. Great. So we have a MERN stack application, which is MongoDB, Express, React, and Node.js, and we have deployed that on a DigitalOcean cluster. And for MongoDB, we are using managed MongoDB service of DigitalOcean, right? So the purpose of this demo is I'll try to show you what a real production ready OpenTelemetry setup may look like for you, right? And we'll try to give you a complete picture. We'll try to give you a complete picture of what we have been talking about till now, infrastructure and application together, right? So we have this front end application, right, which is sort of a simple coffee shop sales counter. If you increase the counter, it will make the call to the backend, and the backend will in turn make the call to the MongoDB database, right? And for OpenTelemetry setup, we are using Randoli, right? Randoli is an OpenTelemetry native platform. It gives you a complete OpenTelemetry setup, production ready out of the box for metrics, logs, and traces, right? And you just need to instrument your applications to emit the telemetry and send it to the collector. So if I do kubectl, I hope it's visible. Should I increase the size a bit? Okay. So k get pods minus n simulation. If we see what's running in the cluster right now, we have a hotel brew hotel brew backend, and the front end service, right? And as I mentioned, it's the managed MongoDB of DigitalOcean, so it's connecting to that as well. Now, what I've done is it depends on how you instrument your application, right? Because I'm a developer, I have used code-based instrumentation, right? So what we are doing is we are sending the metrics and the traces to the OpenTelemetry collector, which the Randoli agent provides out of the box. And whenever we make any request, we are sending the metrics and we are sending the traces, plus the logs are being captured automatically, right? So how does that look like in terms of visualization? What I've done is I've set up Grafana on this particular cluster. So if I reload the dashboard, let's see what happens in Prometheus. So, and by the way, if you whenever you set up the Randoli agent, you'll get Prometheus for metrics, integrated logging with Loki. This is something we released recently, and you'll also get Tempo to visualize your traces. And I'll tell you how this all unifies in a single pane of glass, in a single dashboard. But let us search for a metric, any metric we can do, right? For example, HTTP client bucket, and for the label, we'll select service.name, hotel backend, and we'll run the query. So this is just last 5 minutes real metrics. So we are getting the metrics from the backend, right? Because the backend is the one which is doing the main processing. So we are getting the metrics from there. Talking about the traces, as I mentioned, Tempo is something that we are using. So if I refresh this page right now, if I take any of the recent request, let's say for example here, I click on this and something happened. Is my screen stuck? Yash, can you please confirm?
No, I think I can see your screen. I can see your dashboard right now. Grafana dashboard.
For some reason, it's stuck for me. Okay, let me reshare that. Sorry, people. I think the demo gods are not with me today. Okay. What I can do is I'll try to share my screen again. Just give me a second, folks. Okay, I hope you're able to see my screen now. So I generated, by the way, I generated some of the request. And if you see the traces right now, if we open, the Hotel Brew front end, which is the fetch counters, now because we were talking about correlation, right? So this is a typical distributed trace. And what I mean by correlation is from the front end, it's making the request to the back end and all the way to the database. Now you'll ask, Kunal, front end is a browser. How are you taking the data from there? Here is the concept of edge collector, which I covered in the very first practice, right? So we are using an edge collector which sits between our main telemetry pipeline and the front end browser. The browser is sending data to the edge collector, and the edge collector is sending the data, specifically traces right now, not metrics, just traces. I've configured only traces for now, to our main OTel pipeline, right? And that's how things are working. So even if it's a browser, we are getting end-to-end traces from the front end, from all the way to the back end. And you can see a couple of details here. Randoli edge collector, that's the name, and Hotel Brew front end. These are the attributes which I was mentioning to all of you. Deployment or environment. These come pre-configured with the OTel pipeline that we have, and you can view here. Similarly for logs, right? So for logs, we have integrated logging with Loki. And what you can do here, if I run the query, so you'll be able to view the logs right here. I'm where do I do this? Okay, so these are sort of the there's nothing special to view here from the front end. I haven't enabled any good logging for front end, but we are getting the logs. But the difference all comes, right? All of this is OpenTelemetry data, right? Everything is instrumented by OpenTelemetry, sent through the pipeline and sent to these particular backends. But let's say you want to view a unified view. I was talking about infrastructure and the application, right? So for the infrastructure, if I reload this particular screen, so this is basically the infrastructure side of things, right? So here, if you see, this is the infrastructure overview. It gives you the entire view of the infrastructure, multi-cluster view, something which Yash talked about. We need a multi-cluster view across different clusters if you're using, right? So this view gives you that. This is the DigitalOcean cluster, which is running right now. If I open this, we'll be able to see certain information like CPU memory usage, because we don't have any persistent volumes. This is a demo environment, so we don't have it yet. But we are able to see all the different event timeline, and this event timeline plays a very important role when we are viewing from the application's perspective. I'll come to that point as well. But you can view the node details. You can even view the network map. So network map gives you a visual view of what is happening, right? So you can see that. I hope everyone is able to see this. So we have an Nginx ingest controller, which is serving the front end. That's how it's connected. And then we have an Hotel Brew backend, which is connected to the Hotel collector, and that's how these services are connected with each other, right? So network map gives you that entire view from the infrastructure. But what about the application itself? So this is what I'll do is I'll reload the page again. All right, so this is basically the APM, right? This will give you the view from the application's perspective itself, right? And what I meant by converting raw telemetry to signals, these are the signals, right? So the red metrics that you see: inbound latency, inbound request rate. So these are generated out of the box, and that is what I meant by getting the raw telemetry from applications, converting that to signals, right? And that is what we will use while you debug any service. So you can click on any of these, and you can see that there are certain things which are happening here as well. We are getting the alerts. And Kunal, what about logs, metrics, and traces? I want to view my raw telemetry data itself. So what you can do is you can go right here fetch telemetry, and this will give you a view of the raw telemetry of that specific pod. So this is the backend pod right now. So memory usage, CPU, network usage. Again, the red metrics chart that we have. We currently don't have any inbound error rate because there are no errors for this one. So that's why it's not showing. But what you can also view is the span metrics, right? Breakdown by different operations, right? So how this is possible? Everything is OpenTelemetry data, first of all, right? And because everything is flowing through OpenTelemetry and we have defined those attributes correctly, that's why you're able to see, you have the visibility into the inbound and outbound latency. That's why you have the visibility into the red metrics as well. What about the logs? So if I click on logs, I can see my logs right here for the backend, right? I can filter out the logs, with this integrated logging with Loki. As I mentioned, the same logs that we saw on Loki are visible here as well. And we can view a particular distributed trace as well. So for example, if I, let's say, go on to any of this particular trace, let's maybe select the latest one of the latest ones. Okay, so if you can see, again, this gives us the distributed trace, entire distributed trace, right? So from fetch counter to get, and we can increase it and try to find the size. So we have covered the unified view, right? Logs, metrics, traces, events as well. Sorry, I forgot that. As I mentioned, right, there needs to be a correlation between infrastructure side and application side. What is happening in the infrastructure, what is happening in the application side. So in this particular timeline here, if you can see right now, because everything is hotel data, right, this correlation happens out of the box. So here I'm able to view what is happening in the infrastructure side of things, what is happening in the host, and what is happening in the application. If there are any errors in the application, it can help me to correlate with the infrastructure. For example, if let's say I switch to the last 12-hour view because I've been doing some testing on here, you can see that I, like, for example, here a workload monitor was triggered and something happened in the infrastructure at the same time. So this helps me to correlate that, all right, something happened in the application, it might have been caused due to the infrastructure, or something happened in the infrastructure, it might have caused something to happen in the application, right? So the same thing that we talked about, these both contexts are needed for us in order to debug and troubleshoot any particular incident. Now, one particular aspect, the last one which I want to really cover right now, is visibility into the observability pipeline itself, to the OTel pipeline. That's one of the practices that I mentioned, right? Something that we have worked on is this particular view. And if you can see here, this is, by the way, our dev environment right now where a lot of testing is going on. So that's why it looks pretty complex, kind of like a real production. This is how it will look like for you as well once you have deployed this in your production. But here you can see multiple OTel pipelines are connected with each other, right? You can see which pipeline is connected with each other because eventually you'll be using multiple OTel pipelines. And you can also view the metrics of one particular pipeline. So for example, I've already opened this particular page. So something which I also mentioned is, you need to monitor the health metrics, right? So these are certain health metrics that we are monitoring. For example, what are the spans received, what are the metric points, how the exporter queue is working, right? What's the size of the queue? You can filter out based on what you want. But right now we are not doing the logs, so that's why it's not displaying. But the main point is that it's important for you to monitor your collector health metrics itself, right? Because that is required for the stability of your collector, because your collector is the main meat of your entire pipeline, right? So with this particular setup, I hope I was able to explain you, right, how this looks like, how this may look like in real world, right? And because again, we are OTel native, Randoli agent is OTel native, so all of this is OpenTelemetry data. It's just that it gives you a unified view of all of the different signals that you have. Alrighty, so let me just, I hope this makes sense, and please let me know if you have any questions in the chat, and I'll just share my screen again. We are nearly at the end of this particular one.
But it was a great demo, Kunal.
Thank you. Yeah. I hope this clears a bit picture in the minds of the audience as well. I'll share my screen again. Whoop. Delete that. Okay. Present. Okay. All right. So we are at the end of this particular webinar, folks, and these are just quick pointers of what we have talked about. So we have talked about application and infrastructure observability, uh, why these are complementary in the first place, why these are needed together, and OpenTelemetry provides us a unified foundation to get both of these particular signals. We also saw that running OpenTelemetry in production means operating a telemetry pipeline, right? It's not just about collecting raw telemetry data. It's not just about emitting the data, right? It's all about how you operate the pipeline itself. um, some of the best practices that we discussed, right? I gave you an entire checklist of things that you need to consider while you're taking hotel to production. Consistency matters, as I mentioned, right? Across the board, for context, naming and sampling conventions, sampling techniques that you need to use. um, the lesson that here I would love for you to take away is production readiness is all about reliability, scale, and trust. So if you are if your data telemetry pipeline is reliable, you are able to easily operate at scale, and you can you have trust in the data which you are sending, and in turn you have the user has trust on you as well. Yeah, that was it from our end. And thank you so much, Yash, for joining me in this particular webinar today. I hope folks in the chat, you were able to gain some value out of it, right? We covered both of the aspects. And yeah, that is all from our side today. I'll just quickly see the chat if we don't have any questions. Did we have any questions?
I don't think so, but maybe we can give 5 more seconds if anyone have any question.
Yeah,
If they
feel
can
free to
write their question in
questions.
5 seconds.
Yeah, feel free to ask any questions, folks. We love to answer. And I see that 11 people are still watching, so that's great. That's awesome. Okay, we had a comment from Joe. It depends on the incident, but the first thing I usually check is, are the pods up? Okay, that was the answer to the first question which I asked. Cool. Thanks, Joe. Also, never been exploring lately, and the whole session really insightful and crisp. Thanks means a lot. Yeah, OpenTelemetry is something which is people have been talking about now in the recent times, and it's important to understand how to get started, but it's also important to understand how to scale, right? How to run it in production. So, and that is the aspect that we covered today. All right. So I don't see any questions, but if you have any questions, you can feel free to comment down in the YouTube channel, or we'll put the recorded video as well. But if you want to comment down, you can comment down in the LinkedIn live stream as well. Feel free to reach out to Yash and me. You can find us on the socials with this particular name right here, and we both are very active on the socials. Yash, any closing remarks from your side?
I think the demo was really great. And those who are actually looking to get their observability, make sure the observability things is figured out and everything is working smoothly, like your MTTR is really, really less. Do make sure you check out the demo again in case you want to. It was a great demo. And yeah, feel free to reach out to us if you have any question.
Amazing. Yeah. And we'll keep doing these webinars throughout this entire year. This is the first one, by the way, Yash. So you are in the first webinar of this particular year. That means a lot. Thank you so much for taking out your time. And yeah, we'll take your leave. Thank you so much, and goodbye.
Okay.
Bye bye.
Bye, everyone. Thanks for having me, Kunal. Bye, everyone.
Thank you.